Welcome everyone. In this video we will look into how a 2D vector transforms in case of a rotation in the axes. So what I mean is, if there is the xy coordinate plane, the classic coordinate plane, if we have this and there is a vector which we can call A, vector A, let's say it makes an angle of, I don't know, like theta with the horizontal, and we are going to rotate the coordinate system. And how do we rotate the coordinate system? Let's say we rotate it in the counterclockwise direction, so in this direction, and the new coordinate plane looks like this. Let's say this is the x prime direction. Let's say this is x prime and this is going to be y prime direction. All right, and you might even want to put like unit vectors to specify that they are unit vectors. And this is not how we call it a prime. Hold on, let's do it like this if you want. Okay, so this is x prime, right? That is what we mean when we say x prime. We don't mean this, which would be like x bar, I think. Yeah, that would be x bar, and this is x prime. Then y prime, and let's put the unit vectors to specify that. Well, to specify that these are just directions. You don't need them. You need them if you find them confusing. But I want to put them. Okay. And let's say that we rotated the original plane by the original coordinate system by an angle of phi. All right. The question we're asking is, if this vector had coordinates x and y initially, what are the new coordinates if we are interested in the coordinates with respect to the new coordinate system? I want to highlight that we did not change the vector. It is still pointing to the same direction. We could have also done this, and this would be a different question. Even though the end results are similar, and I am saying similar, they are not the same. And similarity doesn't mean that they have something to do with each other, of course. Well, let me explain it, okay. We could have also done this. We have vector A, the same vector A, let's say, with angle theta. And this time we rotate this vector A by an angle of phi. So this angle is phi. And now we have a new vector which we can call A prime, let's say. Here we transformed the coordinate system, and here we rotated the vector. These two scenarios are not the same, even though the end results look similar. I want to highlight this. And in fact, I have a video about this scenario number 2. You can access that video from the cards right now and also from the descriptions part. In that video, I also talk about the distinction between the two. So yeah, you can also watch that to enhance your understanding. So why did I tell this? Make sure that you understand we are not doing this in this video. We are doing the first thing that I described, which is rotating the coordinate system, and the vector stays the same, but the coordinates will change because we are looking from a different perspective, let's say, okay? So the coordinates will change. And what we want to do is, we have x and y, and there is going to be some sort of a matrix acting on this, and which we can call the transformation matrix, let's say. There's going to be a 2 by 2 matrix acting on this xy. And as a result, we are going to get the new coordinates, which we can call x prime and y prime. Our goal is, in fact, to figure out what this transformation matrix is. We want to find this part. And it is going to have 4 elements. And I discussed this part very briefly in this video. And why do I say briefly? Well, how do I know that this is going to be 2 by 2? Because the only two things that I know is I start with these and I want to end up with these. Maybe I can use a 3 by 3 matrix here. Why not? Who knows? Or maybe it doesn't need to be a square matrix. It can be 2, 2, 3. And I mean, it can't be. I'm just like posing hypothetical questions. It must be 2 by 2, but why is that? And also, why is it even on the left of xy? Maybe I can put the matrix here. Why is it that the solution must be in this form? I talk in great detail about this for like a couple of minutes, I think, in the video that I just mentioned. So I would strongly suggest that you go ahead and watch that video, or at least that part that interests, that concerns us for the reason why this must be a 2 by 2 matrix and it must be on the left side of the vector xy. Okay? And, well, again, the fact that same argument applies here as well, because this is mathematically the same thing. However, the elements in the matrices, the transformation matrices, differ in the two videos. Okay, in this one we will find a different matrix than that in the other video. All right, even though they will be both 2 by 2. Okay, enough said. I think I talked too much. Let's get into the calculation. So to find the new coordinates, we want to take the projection of A along the new axis. So we are going to draw a 90-degree dashed line like so, and this angle is going to be theta minus phi, right? That is theta minus phi. And this part is going to be the x prime, and this part, let's do it with a different color, with orange, let's say. This part is going to be y prime. Okay? So what can we say? Well, then we can say, let's see, we can say that y prime is equal to the magnitude of A times sine of theta minus phi, right? And for x prime, we could say it equals A times cosine of theta minus phi. Okay? And, well, okay, we got this. And we also want to find the old coordinates as well in terms of the angles and the magnitude, because we are trying to relate the old ones and the new ones. We need expressions for both then. What is y? Y is going to be A sine of theta, and I hope the drawing isn't very confusing, but this is the y component, the initial y component, and that is opposite if we are considering angle theta. And then x is going to be a cosine of theta. And notice that we were able to use the same magnitude here, because we did not change the vector. We did not change the vector at all, so its magnitude will not change just because we changed the coordinate system. And even if we were to rotate the vector, we could rotate it such that the magnitude would stay the same. But we are not even considering that case because, as I said, we don't change the vector in this problem. The vector stays the same. Only the way we express the vector is changing because we are changing our coordinate system. The vector still points to the same point on the space. Okay? Cool. So now I want to open up this expression and this expression. Let's do that. So x prime is going to be A, and what is cosine theta minus phi? I have a video where I derived the formula for this. You can access that video from the cards right now and also from the descriptions part. And same thing goes for sine of theta minus phi. I also derived that in a previous video, which you can also access from the corresponding links. So using that formula, which we have already proven, as I said, we know that this is equal to cosine of theta times cosine of, that's not theta though, that's okay, cosine of theta times cosine of phi plus sine of theta times sine of Why do I keep writing phi? I mean, not that it matters, but okay. Sine of phi. And, well, let's let's get rid of the parentheses. This is going to be A. And here, let's see if I can, well, I need to rewrite it. Plus A sine of theta. Okay, cool. What about y prime? Y prime is going to be A sine of theta cosine of phi minus A sine of phi. Let's write the cosine first because there's a nice pattern. Cosine of theta sine of phi. Okay. Fair enough. And look at this. What is A cosine of theta? That's x. X cosine of phi. Plus, what is A sine of theta? That's y. Y sine of phi. Again, A sine of theta, that is y. So y cosine of phi. And here, and this is in fact y, I wrote the cosine first here to show this grouping more clearly. Okay, so we group this, and here we have A cosine of theta, which is x. We also have the minus up front, so minus x sine of phi. Okay? And with this being said, we are in fact done. Okay, we transformed the, well, basically, if we are given the old coordinates and the rotation angle, we can figure out the new coordinates. And this is all fine. But if we were to express this in a more concise way using matrices, we could do it in this way. We would have x prime, y prime. This is going to be equal to cosine of phi, sine of phi, and then minus sine of phi, cosine of phi. Then we have x, y. And you might be asking, you should be asking, I mean, if you haven't looked into matrices in detail, you should be asking, how did you make this transformation? I mean, how did you figure out that this would be the transformation matrix? And, well, honestly, I did so by observation. And what observation did I make? Well, if we are doing matrix multiplication, the way we do it is, we are going to take this and multiply it with this. And then we multiply this with this. Then we add them up to get this guy. And that is what's happening in the first equation. Furthermore, we take this guy, multiply it with this guy, and then this guy is multiplied with this guy to give us this guy. And that is what's happening in the last equation, in the second equation. So that's how I did, how I was able to summarize the result in this way by just observation, okay? So this is it basically, yeah. Anyways, I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. So for that, please make sure to subscribe. And this is it. Hope to see you in another video. Until then, take care.